All right, let's go through the last set of solving radical equations. Now, some of these questions are going to become more complex because when we square things or cube things or whatever, it's going to be more difficult to do that to the other side of the equation. So I'm going to zoom in on number 9. First thing I want to do is look for my radical. And my radical is already completely isolated. So I am going to simply square both sides. Now, this is the part on the left side where we've got to be careful. First semester, we did some work with multiplying our expressions here. And so what you need to remember is x plus 2 squared is really x plus 2 times another x plus 2. On the right side, the square and the square root will cancel each other out, and so you're just left with 3x plus 10. Do whatever you need to multiply x plus 2 times x plus 2, distribute, if you know the FOIL method, do what you need to. I'm going to clean up this left side, so x squared plus 4x plus 4 is equal to 3x plus 10. Now, we have a quadratic. And so because I have a quadratic, I actually want to get everything to one side of the problem. So in this case, I'm going to subtract 3x and subtract 10. So we've got x squared plus an x minus 6 is equal to 0. This is factorable. So what multiplies to negative 6 and adds up to 1 is going to be plus 3 and minus 2. Just doing a quick check in my head, it is, which gives me then x plus 3 equals 0, x minus 2 equals 0. Each factor gets that equal to 0. So I have the possibilities of x equals negative 3 and x equals 2. You have two possible answers here, which means we have to check two possible values. So first thing I'm going to do is check x equals negative 3. So every single place I have an x in the original problem, I'm replacing it with a negative 3. Okay, so x plus 2, so negative 3 plus 2 equals 3x, so 3 times negative 3 plus 10. So negative 3 plus 2 is negative 1. Now, inside the radical here, I've got 3 times negative 3, which is negative 9. Negative 9 plus 10 would be 1. So with the square root of 1, so I get negative 1 is equal to, well, the square root of 1 is 1. That is a false statement. 1 does not equal negative 1. Because this is a false statement, negative 3 is not a possible answer. It's called an extraneous solution. So let's check the other value for x. So 2 plus 2 equals the square root of 3 times 2 plus 10. So 2 plus 2 is 4. 3 times 2 is 6. 6 plus 10 is 16. Square root of 16 is 4. That is a true statement. And so you now know that we had only one solution here of x equals 2. Now, every single thing that we did in this problem was mathematically correct from start to finish. The only way we knew that this answer didn't work is by checking the solution. There's no other way to find it, okay? So that's why I kept stressing you have to check your work because you're not going to know if the answer is right or not, okay? All right, so I'm going to slide over to number 10 here. I'm going to look for my root. My root is already isolated. So I'm going to go ahead and square both sides. So square and square root cancel. So 2x minus 11 equals x minus 7 times another x minus 7. All right, so 2x minus 11 equals x squared minus 7x minus another 7x plus 49. So 2x minus 11 equals, let's just do a little, combine some like terms here. All right, so I want to now get everything to one side and make, in this case, I'm going to make the left side equal to 0. So minus 2x plus 11, minus 2x plus 11. So 0 equals x squared minus 16x plus, I think that's 60. Yeah, it looks like 60. That's factorable. Multiplies to positive 60, adds up to negative 16. How about a negative 10 and a negative 6? So now I'm going to take each factor, set it equal to 0, and then I've got possible answers of positive 10 or positive 6. Okay? But as with the last problem, as with every problem that has a radical in it, you have to check your work. So it doesn't matter which one you check first. I'm going to go ahead and check 10. So I've got the square root of 2 times 10 minus 11 is equal to 10 minus 7. So 2 times 10 is 20. 20 minus 11 would be 9. So the square root of 9. 10 minus 7 is 3. So 3 equals 3. Yes, I can now guarantee you that x can equal 10. Now, that does not automatically mean that x equals 6 or can't equal 6. With these problems, you could have both solutions work. You could have neither solution work. There's lots of possibilities here. So whatever you do, just check your answers. So I'm going to go ahead and check 6. So 2 times 6 minus 11 is equal to 6 minus 7. So 2 times 6, 12 minus 11 is 1. 6 minus 7 is negative 1. That's a horrible one. Hold on a second. There we go, 1. So square root of 1 is equal to 1. So 1 is equal to negative 1, and that is false. And so that tells me that x actually doesn't equal 6. So in this particular problem, we have one real solution of x equals 10 and one extraneous solution or extra solution of x equals 6. All right, let's go ahead and slide on down to number 11 here. Problems are getting slightly more complicated each time. So we have a radical right here, but there's something on the same side as that radical, which in this case is a negative 5. So I want to get rid of it. I'm going to add 5 to both sides. So x minus 7 plus 5 would become x minus 2. And then I just have the square root here of 6x minus 5. To get rid of the square root, I'm going to square both sides. So x minus 2 times another x minus 2. Square and square root cancel, so 6x minus 5. Do a little multiplication here. I'm going to do a little combining like terms. Plus 4 equals 6x minus 5. Now, again, we have a quadratic here, so I'm going to get rid of the right side in this case. When I do these problems, I'm always looking to keep the x squared positive because that's easier for me to factor then. So speaking of factoring, so what multiplies to 9 and adds up to negative 10? That's going to be negative 9 and negative 1. So x minus 9, set each factor equal to 0. So we have possible solutions of x equals 9 and x equals 1. But I'm saying they're possible solutions because I don't know. We need to check them. All right, so let's check. Go back to the original line of the problem, and everywhere I have an x, I'm going to replace it with a 9. All right, so 9 minus 7 is 2. Negative 5 plus, let's see, 6 times 9 would be 54. 54 minus 5 would be the square root of 49. So negative 5 plus square root of 49 is 7. Negative 5 plus 7 is 2. That is a true statement. So 9 is a possible solution. I need to check and see if 1 is a possible solution as well. So every place I have an x, I'm going to replace it with a 1. All right, so square root of 6 times 1 minus 5. Let's see, 1 minus 7 would be negative 6. Negative 5 plus, let's see, square root of 6 times 1 is 6. 6 minus 5 would be 1. Square root of 1 is 1. Negative 5 plus 1 is negative 4. That's false. Negative 6 does not equal negative 4. So x is actually not equal to 1. So again, every time you're going to check these problems, make sure you check all your possible solutions. We can have problems that have 2 solutions that work, 1 solution. You could have a problem that has no solutions that work, okay? All right, last one, number 12 here. Find your radical. I have found the radical. Get rid of the stuff that's around it. In this case, we've got a -4, so I'm going to add 4 to both sides. So I've got the square root of 2n plus 81 is equal to 9. I'm going to square both sides of the problem. So 2n plus 81 is equal to 9 squared is 81. I'm going to subtract 81 from both sides. So 2n is equal to 0. I weirdly have some students get weirded out about this part. So I'm going to divide both sides by 2 and n is equal to 0. Maybe, I think, kind of, sort of, I hope. All right, but you got to check it. So if we check this, we're going to replace n with 0. So -4 plus the square root of 2 times 0 plus 81 is equal to 5. So -4 plus 2 times 0 is 0. 0 plus 81 is still 81. So the square root of 81 is 9. -4 plus 9 is 5. 5 is equal to 5. That is true. So n is equal to 0. I don't know what happens every once in a while, but when students get an answer where the variable is equal to 0, they kind of have some strange reactions sometimes. 0 is just a number, all right? So it is totally acceptable for your variable to equal 0. You just have to check your work. All right, so that's the last of the equations that are on this note sheet. If you've got any questions or concerns, please reach out and ask. And again, I'm going to keep stressing this, but make sure you check your solutions when you do this work.